Mickey says 9:01, so maybe it's time for us to go ahead and get rolling. So thank you very much for your time. My name is Derek Oliver. I am your friendly neighborhood Google Cloud engineer, and I come to this domain by way of a discipline called operations research. So while I'm here, operations research, ring any bells with anybody? Kind of an applied math, modeling, simulation, optimization kind of a discipline. And data science borrows from a lot of those ideas or principles. So before I start, let me get a show of hands real quick. Who's in the room? Any machine learning engineers in the room? Okay, how about data analysts? There we go. Data scientists? Data scientists? Software developers? Educators? Educator, okay. Any PhD types? Okay, yeah. All right, excellent. So want to get a sense. Anybody on the Zoom respond to who's in the room? Okay, and that's always kind of helpful to kind of get a sense of who's here and what we're going to talk about. So title is Data Meets Gen AI, turning data into educational intelligence. So I'll kind of walk you through a series of chapters, if you will, the way the preso is broken up. So feel free to interrupt, feel free to ask questions, and feel free to challenge. So I have thick skin, so I'm happy to take difficult questions or things you say, wait a minute, Derek, what are you talking about? That doesn't make any sense. So don't be shy in that regard. So with that, we'll go ahead and we'll get rolling here. Let's see if I can, maybe I'm too far away. Oop. Okay, well, let's see. We click here. There we go. Okay. So as we embark on any journey, it's always good to know what's the end state. Where are you going? And from a vision standpoint, this is it. Let's make this thing called generative AI accessible to all enterprises. And this is very close to the mission of Google, which is to organize the world's information and make it universally accessible and useful. So that's our end state, and that's where we're going. Now, along the way, there are some bedrock foundational principles, and this is pre-technology. So I'll jump into these real quick and tell you that we are hardcore committed to the things that AI should do. It should have social benefit. We should minimize bias. And while I'm on bias, we could probably have a whole separate conversation around bias. I've had, let's say, enlightened debates about bias and whether or not your interpretation of bias is the same as mine, what it means. Can you eliminate? My opinion, my personal opinion, you can minimize if you're diligent with your model training techniques. Built for safety, accountable to people as opposed to policies, incorporate privacy design principles so that AI is never allowing your personal information to be distributed, uphold high standards of scientific excellence, and be available with the core of those principles. So similarly, we are not going to do these things on the right-hand side. Again, this has nothing to do with technology. This has to do with the nature of how we operate in this domain. Not going to cause harm. The principal purpose of the AI is to enact direct injury, surveillance violating any international terms, or the purpose contravenes international law or treaties. So those are, and I think this is really, really foundational to the rest of the process. Internally, there's a very rigorous process that we go through before we make any decision to release or enable AI or ML or deep learning. So foundational, we'll start there. Now, we also think that it's important to understand kind of where you've been. If you look at your history and your lineage, may give you some indication of where you're headed. So over 3,000 researchers leveraging our technology, 7,000 publications, but this is probably a better picture. So let's go back to 2017 with the Transformer, moving to 2018 with BERT, kind of the first language model, 2019, text-to-text transfer transformer, then Lambda, then AlphaFold, Palm, and now 2023 with Bard. And I put this up to give you some understanding. We've been heavily involved in the AI landscape for quite some time now. And even if you go back to 2017 and you think about, let me just kind of pause here. Transformer, ring any bells to anyone in the room? Just kind of, you know, that's kind of the architecture that has given the unique rise to LLMs in the recent past. Going back to 2017, the Transformer and all of this progress, I still think that we are just barely scratching the surface. And you'll see that in the next, you might even find that the advancement, how fast we move in this domain, what happened 6 months ago will be a commodity, you know, in the next 6 months. So just giving you some perspective there, okay? Now, the chapters. So this is chapter 2. I'm going to give you some perspective. And I think this is really important to kind of level set because I hear terms tossed around. Again, remember I told you I'm an operations research guy. So, and I'm also a 20-year Air Force veteran. So I kind of look at things in buckets, and I want to bucketize these terms so we get a very clear understanding of what we're talking about here. So let's start with artificial intelligence. So any technique that enables computers to mimic human behavior. So this is the umbrella term. This is AI. And we're talking about chatbots, rule-based systems, and robotics. Now, beneath AI, we have machine learning. And this is a technique that lets computers learn from data without being explicitly programmed. So it's kind of flipping the model upside down. Instead of banging on the keyboard, let's take an algorithm, let's expose it to data, whether that data is labeled or not, and let's learn from that. And then finally, decision trees, k-nearest neighbors, and regression models. And in the lower right-hand corner, coming down even further, a subset of machine learning is called deep learning. And this is to solve more complex problems. Now we're going to use this thing called an artificial neural network. It's not the same thing as the neurons in our brain, but it's analogous. And it's important to understand that that technique, deep learning, lets us solve problems that are significantly more complicated and is the foundation upon which a lot of our LLMs operate. Okay? AI, machine learning, deep learning, and I'll tell you, I'll refer back to this a few times as we go through the presentation. So deep learning uses these artificial neural networks. We've dropped the artificial and we just call them neural networks, and I'll show you a picture of that here in a second of why this is important. But again, it's just level setting so you get some perspective about, when we talk about AI, ML, deep learning, you notice that I haven't said anything about Gen AI yet, and it wasn't on the previous slide. Now, I'll point that out here in a second. So what you see here is a representation of a neural network. And I bring this up because I've heard, has anybody heard this term that it's just kind of a black box? It's just magic? In my humble opinion, it's not magic and it's not a black box, and I'll tell you why. You have input on the left. So just think of a lot of data coming into a model. You have computation, you have math, a lot of linear algebra happening in the middle with matrices, and then you have outputs on the right. So at the end of the day, what you're seeing here is just a representation of data coming in, a lot of math happening in the middle, data coming out. Now, does it get significantly more complex? Sure it does, but this is the basis upon which the LLM and the neural networks operate. Okay, let me pause there. Am I making sense? Are there any questions? Everybody's following? Okay, excellent. Now, generative AI, if you go back to my picture with AI, ML, and deep learning, Gen AI is a subset of deep learning. So do you see how we're nested? We're kind of down here in a subset of a subset of a subset, and that's important to understand because as generative AI becomes more commoditized, I believe that we'll find other techniques that will even help generative AI become more efficient, fewer hallucinations, and I'll show you that here in a second as we move down the presentation. So now I'm going to show you some examples here of discriminative techniques. So a model that's used to just classify. You know, it's got labeled data, and you see the picture there. We're going to see a dog, classify that dog, and it's going to give it a label. So it's just seeing the relationship between y equals mx plus b. And down at the bottom down here, we're going to generate new data, and therein lies the term generative, right? We're going to understand the distribution, and we're going to predict the next token. Give me the next word in this sequence, and that's what the generative models do, by and large, okay? So again, this is the perspective section, just so we can kind of set some things up for later in the talk. Okay, so to this point, I've told you one thing about Google, and that was mostly our principles, what we're going to do with AI and what we absolutely will not do. But let me tell you why Google overall, from a engagement standpoint. First and foremost, it's your data. It's your sensitive, your proprietary data, and we are committed that your data remains your data no matter what. Second of all, we understand that bigger is not always better. Yes, we're talking about LLMs, but there may be times where a small model is sufficient. A small model is more economical, and we're happy to give you the opportunity to use our platform to go large, medium, small, or even custom if that's better for you. It's important to understand, it's cool that the model gave me an answer, but it's better when I know where the answer came from. Give me some context. Help me understand the lineage of this information coming out of this model, and I'll feel a lot better about the results. Let's make it easy. Give me a nice, clean UI. You know, you've heard this term, ClickOps. I don't want to have to go deep into your UI. I want to be very simple, very straightforward. Let's make it easy for me to use your tool. And then finally, we understand that you need performance, you need security, and you need scale. That way you can grow and you can expand. You don't have to start your model building process and go, well, I'm at the end of Google's limits, so now I've got to go somewhere else. So these are the reasons that we believe we are an excellent partner for all of your end-to-end machine learning needs. Okay? Now, so that was perspective. Chapter 3 is enterprise. And now we're going to talk a little bit of education. And if you look at, so ASU, in my opinion, and what I know is it's a vast universe. It's even bigger than I thought it was. And from a size standpoint, if ASU is not an enterprise, I don't know what an enterprise is. So let's take that and kind of run with it here. Key issues for education with respect to enterprise, these are 3, and I'm sure there are others, but privacy, safety, and appropriateness. You know, like any enterprise, you need the ability to ebb and flow, to modify your policies as your needs dictate. And we understand this is an integral part of your value proposition. And in some cases, it becomes not whether it's AI or no AI, but it's which AI in which context and for what purpose. And we want to help you kind of walk through that process, okay? Now, I listed some challenges here, and the next slide is opportunities, but these are not the only challenges. Let's say there are many of them. But if we think for a minute about education being an ecosystem and having a lot of different tools with a lot of different configurations, you know, that could be difficult to operate at scale. Education being an enterprise, I just kind of talked about that, privacy, security, appropriateness, you know, we need to help you work through that. Not personalizing AI as much as we could to give that kind of personal assistant feel is important to us. And then finally, right now we may not be the best at helping scale teacher enablement, right? So that's the challenge. What are the opportunities? Well, the opportunities is to help you with understanding perhaps the student journey. Can we use our models, can we use our techniques to determine which students are likely to fall off or which are going to struggle? And then can we then use our models to figure out an intervention strategy, you know, when to intervene, how to intervene, and then can we use that data to get them back on track? Can we personalize AI? Can we make that digital assistant a reality? And it's just like picking up your phone, that your AI assistant is going to tell you about the things that you're going to do throughout your day, throughout your week, throughout your month, and keep you on track from a student standpoint. And then finally, can we inform, advise, and help educators scale and expand? And I think the answer is yes. Okay? Now, if you think about that opportunity and how you bring that to fruition, this is an example, this is a model of how we can put something together like that. So, show of hands, OpenAI, ring any bells? Okay, looks like it does. Anthropic, ring any bells? Okay. Cohere, yeah. Our end-to-end platform is called Vertex. So whether you're talking about OpenAI or Cohere or Anthropic, pick your model, which could even be a custom model. It could be a fine-tuned model. We believe that we can take all of those LLM providers, and if you look at the second layer of this picture, microservices. So these are services that are distributed that can come together to bring you value through an application. We can bring that data into a service in the middle layer with core service and data models, and we can underpin that with what you see here in integrations. Your student information system, your learning management system for student profile, platforms for credential pathway. So one service for all the LLMs that serves on a common data platform, and this is actually called the CLP, and I think ASU has some experience with this model already in practice. This is not the way, this is a way, and we feel very strongly that this can help transform some of the power of the different LLM providers from an educational standpoint in this domain specifically. Any comments? Any challenges? Anybody disagree with me? Sir?
What does CLP stand for?
The Cloud Learning Platform. Yeah, yeah. Any thoughts or?
No, I was just curious about what that
Okay,
was.
yeah.
Heard that, the microservice.
Yeah, exactly. Any more comments, questions? Any dissent? All right, so far so good. It's going to get a little more engaged. So I've given you perspective. I've given you the enterprise. Now let's talk Gen AI and Google. What can Google bring to this? What can we bring to this from a technology standpoint that you may not already recognize? So this is our stack, and I'm going to start down here at the bottom. You can't see it because my my chat's there, but on the bottom here, and I think this is critical. This is Google Cloud Infrastructure. Let's just say infrastructure in general. So if I said the term GPU, show of hands. How about TPU, show of hands? Okay. To the extent that we have the computational horsepower to take advantage of all of these advances in AI, ML, deep learning, Gen AI, we can succeed. If we don't have the computational horsepower, the infrastructure, then we're going to find ourselves struggling more and more as this technology advances. So I think this, while it's the bottom, it's the foundation, it's like the thinnest layer, it is critical for us, even as a nation, to stay fully engaged in the development of chip technology and accelerators that can give us the kind of computation we need to move from where we are to where we're going to be. Quantum computing. Anyone familiar with quantum and what quantum's going to? We don't really have the full realization yet because we don't quite have the computational horsepower. That is vital. If I said NVIDIA, would anyone recognize that name? Okay, there you go. So start there. Let's go up to foundational models. These are the models that you heard of, PaLM and Lambda, but they're text, chat, code. They are the models that are pervasive across most of our platform. And in the middle there, so that's the AI practitioner level. In the middle, you see Vertex and Gen AI App Builder. We split those out, but that's the developer kind of integration point. Vertex AI is our end-to-end machine learning platform. So whether you want a custom model, whether you want to build your own model, whether you want to just bring your data to the platform, Vertex AI gives you all of that capability in a one-stop shop. First-party tools, open source tools, third-party tools, RESTful APIs, all of it's there for you to consume. And then finally up top, from a business standpoint, some integration with Duet, with Workspace, Contact Center, Document AI, Discovery, and Healthcare. So in a nutshell, this is our stack. There's an infinite number of details, and I can't show you here, but at the booth, come on over and I'll walk you through it. Sir?
You mentioned quantum computing. Are you able to divulge any alternative computing that Google is working on with their cloud infrastructure
Yeah.
that would solve that challenge of computational limits?
Okay, okay.
Words?
Do you remember the neural network slide?
Yep.
Okay, the hidden layers, the middle. So to the extent that your model is leveraging matrix multiplication, and let's just not say it's 1, 2, 3, let's say it's n-dimensional matrix multiplication, the tensor processing unit, the TPU, our latest version is V5E, is absolutely ideal for that kind of calculation. Now, if you're going to use a TPU, then you're probably going to use TensorFlow, which is a library that you can call with Python. But I believe that technology, the way we're progressing right now, I can't divulge anything that's roadmap, but I think that's going to be a tremendous opportunity to help take care of this thing that I described down here with infrastructure in the future. So the TPU can make your life significantly easier from a computational standpoint if you can leverage that particular accelerator in your model.
Isn't a TPU, doesn't that work off of like traditional silicon computing, like hardware components?
Today, yes.
Yeah. So like quantum works differently.
Correct.
Like traditional silicon computing. So I guess I'm aware of the TPU, but I was more asking about like the like core technology that supports the alternative computing, like the different.
Right.
You might not be able to tell me anything, but I was wondering
Yeah.
if you could. I'm interested.
Should I hand the mic to the question? Can you guys hear his question in the back of the room? So I want you to ask your question again, and the answer is, we're going to have to talk later,
Okay.
because I'm not.
Sure.
You're asking a great question. I want everybody else to hear your question.
Can you hear me?
Yeah, there we go.
Okay. So you mentioned quantum computing as an alternative to the limits that traditional silicon computing
Right.
offers, which is where Google Cloud infrastructure would pose a potential benefit to this whole portfolio. My question was, what other forms of alternative computing, like such as quantum or other forms of alternative computing methods, are Google working on
Right.
to potentially incorporate into their cloud infrastructure system to support this portfolio?
Okay, that's an awesome question. And if I go into those details, I'm getting ahead of my skis with our product team. So I'm going to stand by on that. But let's talk afterwards, and I can maybe point you to some sources that will help you understand what we're doing there. What I don't want to do is to divulge anything that I shouldn't be divulging on a Zoom recording. Jess,
Yeah, go ahead.
you want to pass the mic? I don't think they heard you, Jess. But yes, it's a better topic for us to cover downstream. Go ahead, Jess.
Yeah, so we can actually get you connected with some of the folks that are working on this topic. I'd be happy to make that
Yeah,
connection.
and those individuals will be able to, they understand exactly what they can and can't say. So let's take that there. But that's a great question. And again, my point is we can't get complacent. And when I say we, I'm talking the greater we. I'm talking about, our industry, you as an educational institution. We can't let ourselves get complacent with infrastructure and understanding where this technology can take us if we keep ourselves on par with the infrastructure. Okay? Let's keep rolling. All right, so this is an eye chart, I know that, but I took this is an actual picture of the UI. So over here is what we call the model garden. And remember I told you, one-stop shop for first-party, open source, and third-party tools. So in the model garden, you have all of these alternatives to use a pre-trained model. You can use a custom model. You can build a custom model. You can use an AutoML model. You can use any of the foundation models, and they're all listed here, out of the box, fine-tuned, customized, all callable with an API. I can show you this in our booth. I can walk you through the model garden if you want to see that, but I just wanted to give you a sense of what this kind of represents with respect to our platform. Okay? Let's keep rolling. Your data, your terms. And I put this in here because I'm trying to foot stomp this. If you don't remember anything else I said, he said, well, Google's definitely committed to, it's my data, it's my terms, and we are not using your data to train our models, okay? So if you look at the left and kind of come across with me, the chatbot API, your users, come into your Google Cloud perimeter, your content, your data, your inference, and your security. And the way this breaks out is inside of this green box here with Conversation AI and Enterprise Search, which is now called Vertex Search, we use these adapter layers. And those adapter layers bifurcate, separate us from your data from our Cloud Central hosting on the right here. That's a frozen model, and you see the lock there. And we're going to use external keys to give you the opportunity to manage your keys to the extent you see fit. You know, those are customer managed encryption keys that you control, that you manage. We have no access to them at all. So I just want to make sure this is very clear from a data management, a data operation, you know, especially inside of your domain. It's very critical to understand that. All right. So we had the perspective, we had the enterprise, we talked a little about Google. Now let's talk about security. In my opinion, and I'd like to see if anybody disagrees with me, you can't really have the data conversation without having a security conversation. Does anyone disagree? Or anyone have a different perspective on that? Okay, excellent. So let's talk about that. We've noticed that when you, and it's true, I'm sure all of you have been around for a while, whenever you introduce a new technology, you almost always now have more threats to deal with. And that's what the left-hand side, as we've opened up the door to LLMs, now we see that we have greater threats. I'll throw one out. Heard of this vulnerability called prompt injection? So you've heard of prompt injection? Okay, so just like we had SQL injection, you know, kind of back in the day, kind of. Now someone can inject into your prompt and your model will exact behavior that you did not intend for it to exact. And there are a list of these vulnerabilities. Then we have toil. So toil means that we're working hard to keep things secure, but it's more difficult now because we've increased our attack surface with large language models. And then finally on the right is talent. I can't even tell you now. We've had the cybersecurity industry has more positions that can be filled, and I think that number is getting bigger as the years go by. So how can Gen AI help us with this? And I'll show you a picture of that. So what we can do is we can use AI-powered remediation to reduce our threats. That's one advantage. This is a picture of Mandiant Advantage that's integrated with our security platform. We can do some automation of security controls. So if we can automate the kind of the mundane, routine things that our security analysts do, if we can automate some of that, we can free them up to do higher level thinking. You know, you've heard of this term undifferentiated work. It's like the same old thing I do every day. Automate that away, and it works in security as well, and AI can help us with that. And then on talent, we can also use AI to do some things that are more routine and free our talent up to expand on more difficult problems. Okay? So, not a panacea by any means, but it can definitely help us in these ways. And then same three categories. I put these up here just so you can get a sense of what we're offering in terms of, you know, VirusTotal. This is a democratizing malware, and if you see anything that says, you know, badurl.com or .jpeg, grab that file, put it in VirusTotal. It'll run through about 50 or 60 different malware detectors, and it'll flag an unknown threat. Breach analytics that we offer through Mandiant. For toil, we offer assured open source. Mandiant threat intelligence, Anyone heard of Mandiant while I'm talking about Mandiant? Mandiant is a large threat intelligence organization that we acquired about a year and a half ago now, and they're fully integrated with our security platform. And then on the right, Chronicle for SIM. If you've heard of Splunk, you've heard of QRadar, you know, you've heard of Chronicle, and then Security Command Center, which is our native tool inside the platform. So again, the point here, the takeaway, is that data and security, in my opinion, should always be part and parcel of the same conversation. Now let's talk about ops. So this will get a little esoteric, but I thought it was important because if you think about, do you remember when before we had DevOps? Do you remember that time when developers were on one side of the fence and IT ops were on the other, and you know, never the two shall meet? And now we have a pretty nice, well, some would disagree with me, a fairly nice integration between developers and operations. And I've even heard DevSecOps, so the integration of development, security, and operations. That's all day two kind of stuff. So, you know, day one, everything's new, everything's just kind of coming out of the box. Day two is when things get real. And I think that from a Gen AI standpoint, day two is coming way sooner than we anticipated. So this ops section kind of gives you some insight into what we're doing to deal with the day two realities of Gen AI. Okay, what's the vision? Let's maximize Gen AI through providing managed ops. Just like you have managed services, let's see if we can help manage ops for day two. And I'm going to break this down. So if you go back to the beginning of my presentation, when I remember that slide I showed you with AI and ML and deep learning, this is a part of machine learning that is now being leveraged to help us make more accurate Gen AI. And it's called reinforcement learning. Anyone heard of reinforcement learning? Okay, a couple hands go up. So if you look at the top, this Venn diagram here, a supervised model that has data that's labeled. I'm going to predict the price of a house, and I have zip code, I have number of bedrooms, I have garage size, I have number of bathrooms. I have all this labeled data, and I'm going to use a supervised model to do a regression with numerical data or a classification with categorical data. Then I come down into semi-supervised, which is kind of your natural language processing kind of activities. And then I have unsupervised, so I don't have any labels on my data. I'm going to use some clustering algorithms to kind of tell me where is the data kind of similar, all right? I'm going to do anomaly detection, and I'm going to try to reduce the dimensions. And then finally, on the left, another component of machine learning, remember now, AI, machine learning, deep learning, it's called reinforcement learning, sequential decision making, task learning. It's like trial and error. So I have an agent, and I'm going to teach this agent how to get out of the maze. And if the agent makes a move in the right direction, I'll give it a reward. And if it goes in the wrong direction, I'm going to give it a penalty. And through this integration of rewards and penalties, my agent eventually learns how to get out of the maze. That's just a very simple example of reinforcement learning. Given trial and error at the very bottom here, with an environment, it learns an optimal behavior. Now, I said all that to show you this, because now we're seeing that reinforcement learning is helping us to improve our large language models, which is really, really kind of cool how that fits together, which is why I talked to you about ML and deep learning at the beginning. And so much so, on the second bullet there, it leverages positive and negative feedback, and we're seeing that human feedback is critical to aligning models. So we're actually giving ourselves the opportunity to put human feedback into our LLMs. In the last bullet there, we're seeing speech generation, character error rate decreased by 46%. Code generation is going up by 75%, and summarization, you can't see the percentage there, it's like 60%. Now I'm going to show you a picture of this, and I'm going to walk you through it, so bear with me. All right. So on the left over here, first of all, what is RLHF? Anyone heard of this term? Okay, reinforcement learning from human feedback. and it helps large language models like ChatGPT, InstructGPT, our DeepMind Sparrow, Anthropic's Claude, and it uses reinforcement learning to optimize the learning process. So if I start at the left over there, I'm going to sample from a model, and then I'm going to score that output. So remember I told you risk reward? So this reward function comes through human feedback, or AI feedback, or programmatic metrics. And the power of the human feedback is that I can take human feedback now and give a reward that's more accurate, that's more precise, so that when I go to fine-tuning step, I'm going to update the weights and biases. All those lines you saw on that neural network chart represent weights and biases, and then I run that around the loop again. So reinforcement learning from human feedback, in a nutshell, is helping us significantly improve the outputs of many of our LLMs. So I told you that to tell you this. That capability is natively integrated into GenAI Studio, so it's in our stack already. It's integrated into our MLOps support, so it's native with Vertex. It helps us with enterprise readiness, and it lets us scale up evaluation tasks by comparing it to state-of-the-art technology. So when you use Vertex AI, that capability is already resident in the platform. And I will be candid with you. Competitors are using that technique as well because it's found to be very, very successful in improving the accuracy and output of the models. Okay, I said a lot there. Any questions, any comments? Anybody want to ask, want to dig into that topic? Okay. So let's kind of bring this home now. The differentiators, in my opinion, are qualitative and quantitative. So AI ethics first. If there's anything you remember walking out of here, is that Google is hardcore committed to the principles of what we should use AI for and what we should not use AI for. And we use a very rigorous internal evaluation process before anything leaves the farm. A lot of options: first party, third party, open source. Question. Let me get the mic.
Actually, what you had just said about AI ethics, and then you had just said open source, and that's what I was about to ask
Yeah, good point.
about Vertex and some of these other things you've talked about. But is Vertex AI like open to peer review and like fully open source?
Yeah, so
Or is it just internal is how you're evaluating that?
yeah, great question. So when I say open source, I'm referring to the fact that you can leverage open source tools with the Vertex AI platform.
Got it.
But Vertex AI is a Google Cloud platform managed service.
Mm-hmm.
So no, it's not open source in that regard. But if you were using models that were open source and you can make an API call, then you can use Vertex with that open source tool.
Okay.
All right?
Yeah.
Or a first party, third party, custom, whatever the case may be. You have that freedom. Democratized products, meaning that from an education standpoint, anything that you have access in the platform, we want to make sure that you can leverage those managed services across all of your opportunities. And then that research flows back to Google in terms of the things that we're doing internally that remember that chart I showed you, the history, all of that research is what I'm talking about. That's going to flow back and continue to make our products better and more expansive. Quantitative, we talked about TPUs a little bit, but that's a 35% cost improvement in performance if your model can leverage a TPU. AI research is not outsourced, it's all internal. And if you're talking about, how we put all this together from a cost standpoint, we can give you a flat model, which is kind of a nice way to think that through. Okay. Now let me ask a question of all of you. What do you think with respect to this ecosystem, this domain? Where do you see the difficulties? Where do you see the challenges? And how might we be able to address some of those with either what I've talked about here or something I haven't addressed. Anybody want to take a stab to throw something my way that, hey, you know what? I don't understand, why we need all these large language models to begin with. What's wrong with a small model? Or what's the difference in whether we use machine learning or programming, or does this technology make programming obsolete? Any thoughts or any ideas or anything that's on your mind that's along this avenue? Or have I said too much? Okay, question.
As a student, while we are learning, much of our course can be done by large language models,
Sure.
even though many hate to admit it. So, how can we, as a platform, improve improve the usage of large language models what my question is simple. How do we improve large language models to an extent that we don't need to learn some of the concepts that it can do?
Good point. So how do you improve an LLM if you don't need to understand? Now, I will tell you, in my humble opinion, you should. I was talking to a student yesterday, and he was asking me about, kind of my background and what from an education standpoint, what should he be looking into? And I said, if you're interested in this domain and you have any desire to be a data engineer or a data scientist or even a data analyst, linear algebra is the foundation upon which a lot of this activity, vectors and matrices and matrix multiplication, vector addition, eigenvalues, eigenvectors, that is the foundation upon which, that's why I told you it's not a black box. That math is what you're going to learn in the classroom. And in my opinion, your ability to understand the math gives you the freedom to come up with alternative approaches. Right now, it's all about large models. This time next year, it may be all about small models. This is moving so fast, and I think we're scratching the surface. We'll be standing here 6 months from now, and you'll go, wow, man, that talk that Derek did was okay, but it's so outdated now because we're looking at a whole new set of challenges that we didn't quite recognize. But those who understand the math, in my opinion, can help shape the future because you understand how that process works. So that's just that's not a Google thing, that's just me. I've been through those courses, and I will tell you that it's so insightful when you kind of understand that piece of the puzzle. Is it for everybody? Absolutely not. But to your question, that's what I'd recommend. Okay, who else? Anything less technical with respect to Google in general and cloud products or the cloud itself and education and data and Gen AI, ma'am?
Well, when you talk about the human feedback to the results,
Yeah.
that brings up the immediate question of bias, and it may not even be a venal sort of bias if you have someone in.
Great question. Yeah, let's talk about that. So bias is a tricky thing. And I will tell you, again, taking off my Google hat, as someone who's done this for a few years now in both an academic setting, a military setting, and a commercial setting, bias is very, very difficult to define. To the extent that I can take let's talk about your data for a minute. So data in the real world is messy. It's imbalanced. There's a lot of, nans, not a number, a lot of zeros. There's a lot of data preparation and cleansing that has to happen so that I can give it to a model and get a result that has some value. Now, bias can sneak in so many different ways. Where did the data come from? How was the data sampled? What was the population size? Who paid for the research? Et cetera, et cetera, et cetera. And so it's a very difficult problem to overcome, and I'm not going to stand here and tell you I have the answer. But I do think through disciplined modeling and simulation techniques, you can get your data, you can massage your data to the point where you minimize bias because you've taken the opportunity to use algorithms that do so. I think that driving bias out of a model completely is nearly impossible, but shrinking it down to a minimal percentage is feasible. Anybody heard of George Box? So George Box was a British scientist who was at the forefront of operations research. And George Box said that all models are wrong, comma, but some are useful. Useful to the extent that you got a model is a representation of the real world, and to the extent that it has some real output and it's based on data that's mostly unbiased, I can have faith and trust in those results to make a decision. So again, bias is a whole, we could even have a bigger, more esoteric conversation about bias and what it means to be biased and what has bias done historically to move our society in the direction it has from, a data standpoint. But that's kind of my humble opinion. Great question. Anybody else? Anybody want to challenge me on anything or disagree? I'm happy to take people who are not kind of all in on this topic, because I think there's so much energy here and there's so much momentum. It's almost, if you dissent, you're kind of, well, you're not with the program. You're not moving down the path that we're headed. So, is anybody concerned about this technology? And I'm talking the whole AI, machine learning, deep learning, and Gen AI. Any thoughts there or comments? Sir? Okay.
Yeah, I wanted to follow up on the idea of bias.
Okay.
About the reinforcement learning, the human feedback,
Right.
That whole concept. So that is a part of Vertex, is that right? Mm-hmm. Yeah, and so Vertex can be leveraged in an enterprise setting.
Absolutely.
Based on what application you want it to take and how you want it to work. So would that feedback also then be available to institutions, organizations to implement their own feedback? Like, say if it's an ASU example, and you're using this to help with struggling students,
Right.
Would you let them give feedback? Is that a possibility in how you could apply that?
Absolutely.
Yeah.
Yeah, absolutely. And remember, your data is your data. So to the extent that you bring your data to the model and your data, you understand your data, and you prepared your data, then leveraging whatever part of Vertex, pre-trained model, build a custom model, all of that is your call. And that's going to stay inside of your purview. But the answer to your question is yes. You can certainly leverage Vertex to run your model to whatever extent is necessary and train it according to the principles that are consistent with ASU or any other enterprise domain. Yeah, so we don't restrict any of that capability from those who want to use the platform.
Okay.
Okay, good question.
And actually, one more follow-up. Following from that, I'm concerned a little bit about security, about like maybe false information,
Sure.
bots, spamming of this
Yeah.
input, and maybe that kind of skewing the data that's then,
Sure.
like back propagated into the model to change those weights and biases. So I guess the question then is around security, which you touched on earlier about how that's something that's integrated into this flow, this portfolio. And how does that work with an enterprise like ASU, and where is the security handoffs for that human feedback, I guess?
Yeah, great point. So with respect to Vertex and the approach that we take, it's what's called a layered security model. So to the extent that, number one, you have controls in place, and controls is a kind of a security word for gates that individuals from a least privileged standpoint. So you only have the privileges to do your job and nothing else inside the platform, first and foremost. Then we have services that prevent data exfiltration. So a virtual private cloud service control. So now, least privilege, a VPC service control, we have identity and access management principles, we have organizational policies. So you see where I'm going? We have firewalls, we have DDoS protection. So when you layer on all these different security controls, it gives you the opportunity to be as secure as you can be. Now, I will tell you, and I've had some experience in the cyber domain as well, if you tell me that you're 100% secure, I will say that I disagree with you. It's not if you're going to be breached, it's when you're breached, and how rapidly and thoroughly can you respond to that breach. How can you minimize the blast and then continue to operate through your backups or your DR strategy or whatever the case may be. And this domain is no different than that. So in my opinion, the same robust security principles that keep your normal data safe will work here as well, through that layered approach. Defense in depth, if you will. Yeah. Okay? All right, it's 8 minutes towards the hour. I thank you for your time. I thank you for your questions. If you want to come over to the booth, I can pull up the UI and I can walk you through the model garden. I can show you some of the things in the UI that I've talked about, but I really appreciate it and enjoy the rest of the conference. I think there's a QR code on there too.